Hello. I want to tell you about the VoiceMaster for the Commodore 64 and the Apple II Plus and IIe computers. This product does many things, so many that we have been criticized for giving far too much for the price. The VoiceMaster digitally records speech for later playback. It recognizes spoken words, and it produces an astounding array of music by simply humming or whistling into the microphone, and then prints out a musical score. Lots to talk about, so let's get on with it.
This is Antic, the Atari 8-Bit Podcast. I'm Kay Savitz. Brad Stewart was co-founder and chief designer of Covox, the company that created Covox VoiceMaster. VoiceMaster was speech digitizing and speech recognition hardware for the Commodore 64, Atari 8-Bit, and Apple II computers. Covox's demonstration audio tape describes it well, although the demo tape that I found doesn't mention the Atari version.
First is digital recording. I simply read words into the microphone, and they are stored in main memory with a different identifying index number for each word. I can name and save a word vocabulary on disk. When you play this back in some program that you can easily write, you don't even need the VoiceMaster or other hardware for the Commodore. For the Apple, a small low-cost plug-in music card is required, but this is only for playback. Now that the vocabulary is made, I can tie it in with a calculator program, and I immediately have a talking calculator. Here is an example, and the computer is doing all of the talking, using the words I have just spoken.
2 plus 3 divided by 6 minus 1 equals minus 0.166666667.
This is real speech, not phoneme synthesis. I could just as easily have recorded the numbers in Spanish or Chinese, or with a Boston accent or a Southern drawl.
This interview took place on May 21st, 2020. Check the show notes at ataripodcast.com for links to Brad's Aerosynth musical instrument, his blog post about Covox VoiceMaster, and a video of me playing with my VoiceMaster in 2014.
I always played with electronics as a kid, then I went to college at the University of California, Santa Barbara, and got a degree in electrical engineering and computer science, and started working from there in acoustic signaling devices for use with the Navy and offshore drilling, underwater sonar. And then I went into a company that developed pyrometers for industrial control. These are heat sensors using the infrared spectrum. And then I worked for a division of Hughes Aircraft in satellite imaging. And then my dad, who was also an electrical engineer, had this company going for a few years. And as I was growing up, and I decided to join it. And it was a company called Avalarm. It manufactured pest repellers using acoustics to ward off birds from fields. And it put out extremely loud artificial screeching. And then
Sounds
I
pleasant.
played around with, I was always playing around with computers, and I created, I got a Commodore 64 and said, I wonder what I can do to it. Figured out how to put speech into it and highly compressed speech, and then put together a little simple little voice recognition program. And it says, well, we can turn this into a product, and it called VoiceMaster. And then I took the same principles and basically the same hardware, and was able to attach it to an Atari computer, and then to an Apple and a Commodore, and eventually went to a PC with a card, and then came out with a sound card back before anybody else. And it did much better quality recording because we could use a more sophisticated digital sampling, 8-bit and 16-bit. And then that was still called SoundMaster, and it had voice recognition. And then we added some music capabilities, and it was called the SoundMaster. And then that ran for a few years, and then basically got out of the business. And I did work for several years in right after the fall of the Soviet Union. I was hired on as a contractor to go over there and do a bunch of evaluation of the science and acoustics and signal processing, and did a product that was called Voice Key, which was a voice recognition system using more advanced algorithms for the PC and integrated Windows. And then after that, I got a real job in corporate America, worked for Sharp Electronics of the Americas, and was involved in their voice recognition project that was funded and it was based on an ARM6, which was one of the very first ARM processors. In fact, Sharp was the first licensee of ARM. And then after that, I went to, we developed, besides voice recognition, we also developed SoCs, system on chips. Basically, they're what you're basically the pre-runners to everything that's in an iPhone or a smartphone, ARM-based, with a bunch of memory management units and a whole bunch of peripherals. And after that, I took a job at Cirrus Logic in Austin, Texas, and again, working on ARM projects and audio. And then after that, I went to work with Freescale, which had just spun off of Motorola. Freescale Semiconductor, I was a field applications engineer, so I was able to move back to Eugene, which is where I live now, and was able to work with customers on the Western United States remotely, and also a lot of travel. And that lasted until about 4 years ago. And then I worked for a year at a company called Arcimoto, which builds electric vehicles, and I was doing the telemetrics for them. And now I'm independent consultant again, and I'm doing more telemetrics work and sensor development using time domain reflectometry. And I also have a small company I started called Aerosynth, where I design and build and play with electronic wind instruments.
Very cool. I would like to see what. Normally, I would say this to the end, but let's. I want to see that right now. I'm so intrigued by this thing. So it's an electronic wind instrument. It looks like I don't know, what's it look like?
It looks like a small. I don't know. Think of a maybe an oboe that's in a square, more of an optical or in a rectangle shape.
Okay, and it has little like brass buttons on it.
Actually, these are gold plated, and then I have brass underneath, and then a whole bunch of controls. So this thing has about 35 sensors on it, including 6 degrees of freedom and joysticks, and it's got about an 8-octave range. So if I turn it on, right now I'm playing around with some modeling and a harmonica. So I've got turn up the volume here. So it's like blowing in and out of a harmonica. I can switch over to another instrument. So I can play chords, and also can do things like modulate the sound. Go to a trumpet, or drop it down to a trombone.
Nice.
Or even go fully electronic. So it's basically can mimic any instrument, drums, guitars, because it basically uses a wavetable to store the sounds, and then the various sensors that you apply to it change the pitch, modulate the pitch.
Oh, that sounds nice.
And you can hear this reverb going on there, and I also have other special effects I can add in, like a. So lots of, this has got a fairly sophisticated ARM processor in there with a ton of memory. So, and also has Bluetooth. It's got, this is just a programming lead right now because I'm still developing it, but I can plug it into a regular PA or a guitar amplifier or bass amplifier. I've got bass patches on here too. So here's a little hard to hear over the phone, but. So it'll do a wide octave. So you can wide octave. You can adjust the pitch by sliding your thumb over the keys.
And what's the fingering like? Is it like a particular instrument?
Well, right now I've got it set up kind of like between I kind of customized it. I started with an oboe fingering, and then I started adding things to it to make it easier.
Mm-hmm.
So I can make it a trumpet. I can make it I have an electronic valve, so you can use these bottom keys just like you would a trumpet, or I can set it up like a piano. But basically, it's set up as an oboe. So I got. Let me put the oboe sound back in. So that's an F sharp, F. So basically the same type of thing, but what's nice is that I can shift keys, so I can be playing in the key of B flat. Right now I'm in concert C.
Mm-hmm. Oh, it'll transpose.
If I want
sure.
to change octaves, all I have to do is, if I want to go to a high D, I can do, or just slide my thumb.
Neat. How fun. This is called the Aerosynth.
Aerosynth.
Is this the thing that is a person could buy now, or is it still in development?
No, I was going to manufacture, but it's not an inexpensive thing to make. So what I was thinking of doing is offering it as a kit and providing just the components. The idea here is you would buy the circuit boards and all the parts, and then you would buy a case that you could either make. Basically it would be kind of semi-open source. So I would have the plans to do the 3D printing if you wanted to do CNC cut out of wood, or just sell the case. And you can finish it the way you want, because this is maple, but I also have other ones that are made out of walnut and oak and other types of wood. So basically, you just need a slab of wood, and then I just run my CNC to cut it out, and so I can provide that block of wood, and then people can finish it any way they want. So they can. Some people are really good at putting like starburst patterns, or think of a guitar. How many ways you could how many ways you could customize a guitar. Because it's the same type of wood, you can do the same type of thing. So I could have pearl inlays and flames and all sorts of things going on here if I wanted to.
All right, let's hop in the way back machine. And
okay.
So I understand the first version of the Covox VoiceMaster was the Commodore 64 and worked through the Commodore user port, right?
That's correct.
Okay. And then later you changed it so it would work through the joystick port, and then
right.
Then it could work basically with any of the microcomputers with the joystick port. So let's talk about that time and that transition. And just talk about what you're thinking.
Well, the user port was, of course, the easy one to interface to at the beginning. The Commodore 64 was incredibly popular, and I still have mine, and it's still a great machine. But that you had a port that was relatively easy to interface to. And then we saw, well, hey, this thing is pretty cool. Let's see what we can do for, I had hired on somebody that was also had an Atari 800, and he said, why don't we make it for this? And I said, well, they don't have a user port. And I sat down and go, well, I got this joystick port, and there's a way to sense analog and digital. So I put together something that worked. And because once I had that, then I could run it on the Commodore 64 as well, and also the Apple IIe. So it was at that point, everybody had a game joystick, basically the 2-axis analog controller, and a bunch of push buttons. And that was enough to interface everything I needed to do the Soundmaster. And then internally, I would play back the sounds using the music synthesizer that was built in the Atari or the Commodore. And on the Apple, they didn't have a sound generator, but I was able to get something fairly decent even out of the internal speaker by using kind of a modified version of a sigma delta modulation on the output. So it was half decent.
Mm-hmm. And was it 4-bit recording?
No, it was 8-bit, and then I typically compressed it to typically 3 bits but you had your option. The software that we supplied allowed you to record at different sample rates, mm-hmm. and also utilize different levels of recording. And we provided a little audio editor where you can go in and clip out, audio,
sure,
or the dead space, or change the amplitudes and play around with the sound. I think we were one of the first ones to do that. And the software that we developed was unbelievably fast for those early machines, because everything was written in assembly language. And of course, we didn't have huge displays to work, but it was quite fast, and I think it allowed you to manipulate each individual sample better than a lot of the certainly better than Audacity, which I use a lot today. So it actually allows you to go in a little deeper.
Mm-hmm.
But it didn't have all the features, of course, of Audacity and some of these others.
So on I have the Atari versions of these things, and I've played with the VoiceMaster. I love it. I love that you created it, and please don't take this as a negative. But when I played with it, I mean, the thing that like sold me when I was a kid looking at the ads was that you could hum or sing into it, and it would transcribe your music. And at that point, I didn't know how to read music. It sounded amazing. And when I tried it a few years ago on the Atari, it didn't work well at all. But I listened to on YouTube, there's a audio tape that you guys sent out, and this one was for the Commodore. And on that version, it played perfectly in real time. So it seemed like the Commodore version might have been better, or my humming skills are poor.
Yeah, it might have been. I mean, that algorithm it really depended on the microphone also on some cases. Since then, as a matter of fact, going back to the Aerosynth again, I took that algorithm and I can actually hum into this and generate music as well. So I kind of kept that going.
Finally, let's get to music. All I have to do is hum. So here are some examples. Da 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 da. 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 Da da da. I like that one in particular. The software also has a built-in whistle mode as well as a humming mode. Thus, I can whistle to make music as well. For example,
and I developed a little toy also that I tried to market. It was called a Sing It, and it was like Simon. Remember the game Simon,
Sure,
where it
yeah.
lights up?
Uh-huh.
Similar, but it would play notes, and then you'd have to hum back the correct sequence of notes. And if and the whole goal of the game was to get how far could you get, So and actually, I had improved the algorithm considerably by then, and had more powerful processors. Because at that point I only had, Commodore, they were 6502 running at 1 megahertz, so
Sure.
didn't have a whole lot of horsepower.
Yeah.
But it was still amazing what I was still able to do with it. But since then, for a couple dollars, you can get an ARM 32-bit ARM processor that runs at 100 megahertz. That can do some amazing things. So, a lot of things have changed. But yeah, sorry, it was one of those algorithms that was tricky. It did require a good microphone. And I think the one we provided worked well, but gosh, it was so long ago I don't remember how it was configured. But yeah, I mean,
it was amazing that it worked at all.
Yeah.
Yeah. So how did you get from
that?
That's
it did work for me.
Good. How did you get from creating your first prototype to we're making a company and we're going to make them and mass produce them? How did that process work?
It was done in an existing company, this Avalon company I told you about. And so there was an infrastructure already there. So we had the ability to do light manufacturing. So it was not a big change to start manufacturing when you have, several thousand, 5,000, 10,000 square foot factory. Even though it was still difficult, because back in those days I had to design all the circuit boards and everything with tape and Mylar. So it was, nothing like today. I design a circuit board almost weekly now because I have CAD systems. Same thing with all my models. And so it took a lot of extra work. The firmware was difficult as well, and the software. but we didn't push it real hard, and things were much simpler back then. So, for example, on the on the Commodore 64, I used a program called Sorcerer, which was basically an assembly language development system, which worked quite well, and it went quite fast. But if I were to do it today, I'd try to do it in Python.
Sure. Do you recall how well it sold across the different platforms? What was the most popular? How they sold?
Yeah, it was okay. We made some money off it. We sold maybe 10,000 all told, 15,000. We could have done much more, but I wasn't very good at marketing, and I mean, we had the first sound card basically,
right?
And it was called SoundMaster, and basically everything was copied, and other companies took the idea and poured a lot more marketing bucks into it, and that's history.
Right.
So
I mean, your team basically invented the first PC sound card, full stop, right? Yeah.
Full stop. Yeah, without a doubt. Yeah.
On the VoiceMaster audio tape, it says, the price is so low, people are suspicious of our motives. Was this hyperbole, or was there a story there?
I don't know. Who is that tape produced by Covox or somebody else?
It was by Covox. It was like a free demo tape that you could send away for.
I tried to stay out of the marketing things as much as I could. That was one of the problems. I'm the technologist, so I just it probably was hyperbole.
As I said at the outset, the price is so low for what you get that people sometimes get suspicious of our motives. Well, we hope to sell lots of these for many different computers. We won't make much on each one, but quantities do add up.
But then again, at the time, voice recognition, you couldn't even touch it for under $1,000.
Sure.
So there's some truth to it. I mean, now voice recognition is free, right?
Right, yeah.
But, it's back then it was pretty new and still kind of an exciting thing. And besides the voice recognition, also did the voice recording. It did a bunch of other stuff. Yeah, it was a toy.
Yeah, it was a fun toy. I like it. Later, you came out. Were you involved with the VoiceMaster Junior?
Yeah, I came out with that one.
Okay, was that just a cost-reduced unit, or
yeah,
what
it was just a cost? It was a cost-reduced one. Hopefully, trying to get it in a higher volume. It was probably a mistake, but it had the basic features. But if I were to do it again, I wouldn't have done it. But yeah, it was much less costly to make, and much less costly. If you make something that's cheaper, your margins are less, so you have to sell more. And if you don't sell more, you're taking sales away from your other products. So yeah, it was a good idea at the time, I guess, when we thought about it.
Sure.
Too many beers, I guess.
Do you have any of that stuff anymore? Any of the software or hardware, or there's a few pieces of software for the VoiceMaster that haven't surfaced.
I just was going through some of my old stuff, and I found some of my old manuals and things.
Nice.
Looks like I don't have them right with me handy. Should have thought of it beforehand. But yeah, there was a bunch of things that I had. I don't know where, my office is just a disaster, and I have 45 years worth of shit that I've accumulated, and I have to start cleaning out, doing some cleanup here. But I have a few of the things. I've got a VoiceMaster stashed away somewhere. Some of the later ones I've got. There was one that we made a few prototypes of. Hang on. Yeah, to make this compatible with the IBM PC, we started with a sound card, and we decided to go with something that connected to the parallel printer port. So,
all right, VoiceMaster key. Right.
Yeah, it had a speaker on it,
mm-hmm.
and it connected to the parallel printer port, which computers don't have anymore.
Right.
But at the time, it's a very fast 8-bit bidirectional port. And then you would have in here microphones, things you could plug into, and various goodies. So that was our last product, I think. And then we messed around with a couple other things, but it never really went anywhere.
Well, what else did you mess around? I was going to ask if you had any other unreleased ideas in those early days or prototypes that you
Yeah,
tried?
we had some prototypes of some really nice audio equipment for controlling of audio, sound, and balance, remote control of those types of things before they became ubiquitous now. But this had the advantage that they were real dials, like you twist them. I hate push buttons on remotes.
Sure.
I always like to just use a knob. In fact, my stereo system is still tubes and turntables. So it's just, to me, it's a better user experience. It's just nobody uses them anymore because they're expensive.
Right. Getting back to things that the Atari people are looking for, there was a game that used it called Escape from Planet X that Covox released. We haven't found that.
Oh gosh, it's interesting. The guy that wrote that, he worked for me. Now he went out and he became extremely well known with video game industry, and he came out with a game called Empire, I think, or something like that. It's a board game.
Okay.
And Don Vaccarino, and he wrote that game while he was working for me. And yeah, it's kind of a adventure game, and you would have some choices. The standard old style adventure game where you get 3 or 4 choices,
right.
And then depending on your choice, something else would happen, and you could use your voice to say one of the commands.
Mm-hmm.
And yeah, it was kind of unique. It was something we just wanted to try and see, would it fly?
Sure.
It worked okay. It was, and then other people tried it. I think Nintendo tried. They had a Pikachu voice recognition system that came out for the Atari, or not the Atari, but the Game Boy, I think it was, and it was kind of based on the same principles.
Fun. Any chance you have any of the source code?
Oh God, I have no idea.
Right, well, if you find it, let me know.
I've got a box full of old backup tapes and stuff, and I might be able to find it. I don't know.
Well, let me know if you find it. We'll save that, get that stuff off there.
That'd be kind of interesting. I've forgotten all about that. Wow, it was a long time ago. You really are digging through the past there.
It's my job. What else? What else haven't we talked about the VoiceMaster time? Tell me a story.
I got into this voice recognition thing, and continued it on when I was, like I said, after I sold off Covox. I pursued other software only solutions for voice recognition, and just went in a direction that I should have probably not have gone, because I was going in a direction opposite where the successful voice recognition algorithms went. But I was able to collect, put together some decent products that work quite well, actually. But especially on the early Windows 3 machines, and way early on, and it would run on anybody's sound card, so that was nice. And then I got involved in a project out of China from the university in Beijing that was basically modifying the Sphinx voice recognition, and got that ported into an iPhone, and tried to sell that, but then Apple came out with their own, and that was the end of that. So now I don't want to touch it. But I wanted to go back in the music side of things, because we did have some, the speech thing was another product that we sold, which was basically an audio rendering box that plugged it onto the PC through the parallel printer port. And there was a bunch of we provided with mod players, which the Atari was famous for playing on the ST.
Right.
And so we took those, you could say, play the same mod files on a PC through the SoundMaster, or through the SoundMaster or the speech thing. So, and that was always fun. The resampling, the mixing of voice always intrigued me. And then I got involved in, after I went and worked for corporate America in the silicon industry, the IC manufacturers, as applications engineer, I did a lot of that kind of signal processing, but more than just audio, also including industrial controls and that type of thing. But I've always enjoyed playing around with signals. So, like, even on this on my instrument here, I've got a whole bank of biquad filters, so I can modulate sounds, and I can get wah-wah effects, and I can put in peak and boost filters and all that kind of stuff, all in real time, all written in C. And that part of the code will probably be open sourced, so people can play with their own versions of signal processing. So besides that, I got the reverb, I've got the echo, I've got the chorusing, and all those other types of things.
Can the Aerosynth transcribe what you play on it?
It can, yes. Actually, the voice, the breath sensor in there, it's very wide band, which means it responds instantly. It's got over a kilohertz, which is way higher than your voice pitch. So by humming into it, I can actually measure the first formant of speech, and then track it, assign it a musical note, send it out, assign it a MIDI value, and send it out to the onboard render, or out to a PC or something that's MIDI connected. By the way, this does support MIDI as well, both through USB and through Bluetooth, MIDI over Bluetooth. So this is not just an instrument; it's also a MIDI controller with a whole bunch of analog and other types of aftertouch and all that good stuff that you don't normally get on a keyboard.
Nice. I think I asked you this before, but I'm going to ask again. I'd like a sense on how the Covox VoiceMaster, how well it sold. I mean, we're talking it sold dozens, hundreds, or thousands, and I assume the Commodore sold best, but what do you think?
Actually, it was a PC one that sold the best.
Okay.
But yeah, we sold maybe a few tens of thousands, not real big. You know, it was enough to keep me in beer and live reasonably. You know, I didn't start making the big bucks until I worked for corporate America. As you know, I was paid an engineer wage. This I've been doing for the love of it. Now I'm back semi-retired, and I'm doing this stuff again for the love of it.
Sure. Nice.
And the passion of it. So yeah, not making a lot of money, but fortunately, when I was making good money, I saved up as much as I could, because I learned to live frugally.
Nice. You spoke at the 7th West Coast Computer Fair, January 1982. Your talk was called A Bionic Approach to Speech Processing.
Oh, yeah. Yeah. That was based on some of my dad's work. As a matter of fact, Covox got started by a book that my dad published and sold in Byte magazine.
The Bionic Ear by John L. Stewart.
Yeah, he passed away about 3 years ago, but he was a PhD in electrical engineering. He started this company, and Covox stands for Cochlear Voice Extractor.
Cochlear Voice Extractor. Okay.
Yeah. So he wrote a bunch of, just basically self-published a book, talked about, you know, the human cochlea, how to model it, and some of the cues you get out of speech, and spectrograms, and how the ear works, and how the brain interprets the signals and things like that. And a lot of this work formed the basis. In fact, he was consultant to the early pioneers of the cochlear implants, which are now become ubiquitous. So a lot of the information that was in here was then developed to run on some of these smaller cochlear implant devices. So yeah, so that was I think my talk was about that, and how we were working on modeling the cochlea, and how the nonlinear characteristics of it give rise to things in sound that you can't really see with a standard spectrogram, because of the nonlinear nature of the basilar membrane and a few other things. And it also predicted and modeled some human, what do they call it, psychoacoustic phenomenon, where you would hear tones from, you know, a mixing of two tones, you would hear a third or fourth, which you can't really explain with a spectrogram unless there's some kind of nonlinear demodulation going on in the inner ear. And we were able to show that on this model, that indeed here it is, because of the nonlinearities, and it's backed up by, you know, people, the psychoacoustic that has been observed in people. So I think that was the gist of my talk. I mean, that was so long ago. I wouldn't remember it.
Seems like you remember it pretty well. So it seems like your dad was interested in sound and hearing, and maybe you got some of that from him.
Yes, I did. Yeah, and then I took it the next step because I was a guy that I was brought up to learn signal processing and to work with computers more intimately. He did everything in BASIC, which was programming language of the du jour. That was the most popular programming language back in the Atari days, right? And so that's where his strong suit was. And then of course I went beyond that. I was in assembly and C, and now I primarily program in Python and C as well today. So I took it the next step, and I was also an audiophile. I was involved in design of some very early on high quality golden ear style amplifiers, preamplifiers, very boutique kind of stuff. And so I was really into it. I had, really kick-ass stereo and had some really great recordings, and that was kind of my hobby. So I just wanted to carry on my hobby and my interests, into my work.
Nice. Did you get any feedback from users of the VoiceMaster about how they were using it, or any interesting applications that you hadn't, predicted?
Yeah, there were some people actually using it. Some doctors were using it as a substitute to foot control for positioning operating equipment, things like that. And, there was lots of people were using it for control of lights. People were interfacing to the X10. I don't know if you remember that. It was the first, but predated all this stuff we have today with the turning on your lights and things like that. In fact, I think we even did a demo of that at a trade show using an Atari. We're actually able to hook it to an X10 and turn on a few lights and things like that, which is kind of cool by your voice. But the voice recognition was okay. It worked. It could have been a lot better, but but we didn't have anything like the cloud or the processing power that we have today. And when you do voice recognition, it's being done when you talk to your smart speaker. The only thing it's capturing is the keyword, and then the rest of it goes to the cloud. And the cloud does the voice recognition. That's why the thing has to be plugged in all the time. To really make a point, I wrote an article in Byte magazine on building this was back in 1991 or 2, and actually put the VoiceMaster voice recognition algorithm into an 8-bit HC05 microcontroller that had a whopping 2K of memory and 128 bytes of RAM, and I was able to get 16 words to recognize out of that, and it was published in Byte, and the source, I think I included the source code. Nice.
I will look for that article. If you could send a message to the Atari and Commodore and Apple II people who have played with the VoiceMaster over the years and are listening to this now, what would you tell them?
I say thanks. Thank you so much for supporting us. And I hope you found it interesting, and hope it spawned some kind of enriched your life somehow, and helped you pursue technology as we move forward,
Beautiful. Thank you. Can I get you to play us out on your Aerosynth? Give me a couple of minutes of audio that I can use as a backing track for my outro. It'd be awesome.
Okay, let me see here.
If you enjoy these interviews and would like to contribute, make a tax-deductible contribution to the Internet Archive, a nonprofit digital library that has done incredible things to preserve computer history. Make your tax-deductible contribution at archive.org/donate. Thanks.
Oh, well.
Beautiful. That's a lot of fun.